Hello everyone, I am Shivam Rao. Will be presenting my directed research project of the topic 4D for safety on construction sites. This project is guided by Dr. Jyoti Trivedi and Mr. Suraj Sontaki. Here, the brief contents of the presentation are given. It begins with the introduction, the literature review, and it ends with conclusion and limitations and what else can be explored in the future that is given in the future scope. As we all know, construction projects are of diverse nature and have a lot of independent activities going on. Lot of labor movements, equipment movements is being observed on the construction site on a day-to-day basis. Here, for this study, our aim is to identify safety features, parameters which can be used to implement safety aspects on construction sites. Here, the idea of using 4D BIM and visual planning is being employed to estimate the safety on construction site before the execution of the project has begun. This can reduce the illness, injuries to the construction workers and enhance the safer construction practices. The outcome here are targeted to be an 4D animation of project site where all these safety measures are implemented and the value add comparison between the traditional construction project and the advanced construction project using 4D and visual planning principles can be compared. The next part will explain the literature review process. Prior to the commencement of the research, the literature review has been done and the introduction part says that BIM and health safety has been advancing with the development of newer construction practices and 4D modeling has been playing a good role in the safety and health precautions in the pre-construction and the design stage. While there are still a lot of illness injuries prone to the construction workers and on the construction sites which are likely to be summarized by OSHA's categories like fall from heights, trench collapse, scap collapse, and repetitive motion injuries. Further, the literature review will focus upon the implementation of BIM towards the safety aspects. The research gap from the reviewed and the studied literature is presented here. There are a lot of BIM applications surrounding the construction safety are found, but there are hardly any instances that incorporate prevention measures modeling in the design process. While there is certainly a no parametric Revit family development in BIM kind of study found out, and let's for an instance a brief definition of parametric family is given. On the right hand side we can see the literature review methodology that was figured out for this research paper. While the initial search, abstract filtration and final text, there are the results that will be discussed in the later slides. This section will tell about the data collection processes. The primary data collection method is explained in this slide. Semi-structured interviews with the subject matter expert were conducted. Their opinions and reviews are given in the next slide. Their profile is given here. We can see the experts are of the HSC field, while another primary data collection was done by the help of conducting a questionnaire survey. That is explained in detail in the report that is attached with this presentation. The company profile has been attached of the construction firms to understand the scale of their company, while the semi-structure interviews have revealed that safety depends on project sites and is very varying according to the project and the conditions around the local sites. The reference materials are a lot of available for Indian contexts like guidelines, IS codes and the Building and Other Construction Workers Act. While these construction sites are limited to Indian aspects, other national and worldwide aspects are covered in the secondary data collection. A lot of rules and regulations or guidelines available throughout the world for the safety and health of the construction workers and the safer construction practices. For UK, the Health and Safety Work Act is one of them. In India, the national building codes have their own guidelines. Similarly, here the list of other worldwide guidelines is present. OSHA guidelines, the HSC guidelines in UK, the ILO guidelines and the ISO guidelines. These are all the sources of secondary data that will be referred to the next slides. The list of the standards that are reviewed by the author is given here. These standards are reviewed for the making of safety parameters in the 3D objects and which will be shown in the next slides. It includes the OSHA parameters. There are certain books from Springer, Root Knowledge, and there are several IS codes that have been referred for the development of safety parametric Revit families. Now we will go through the research methodology that is conducted and executed for the study of this work. This is the complete research methodology that has been followed for the study. This is a comprehensive flowchart that shows the tasks, the input, the process for that task, and the output that is derived at the end of the task. Let's take for the example of literature review. So here we have reviewed journal papers and have a definite search strategy, and we got the output of research gap, and we have developed a question based for the primary survey. Now second is the OSHA standards that we have reviewed, and similarly we can have the information regarding the safety clearances and what all objects are to be incorporated for equipments and the other objects on the sites. This research methodology has several tasks like capturing preliminary awareness through a survey, then developing parametric family modeling, then assigning and loading this model families into the pilot project, then integrating this pilot project for the 4D visualization of the project in BIM model integration with Synchro, and then lastly we have the animation output development from Synchro 4D Pro. The data analysis chapter will be discussed. Here we will be discussing the Revit parametric modeling, which will be the development of equipment families with parameters, and we will be looking through these families in this section. Data analysis section. The findings from the study of safety standards is used to model the construction equipment and the safer zones around it. The barricades, the fall protection system, and the safe working zones are modeled, which will be shown in the next slides. Here, for the first instance, we have taken an example of ladders. We have developed caution area with the help of the red zones that is observed in this PPT. We have also modeled cones. The guideline here followed is the OSHA 362504 2018 guideline. It suggests using barriers. Here we have instantly used the cones. These ladders are generally found out for the excavation pits where the worker movement or the inspection personnel can use these ladders. So it must be safe, and it must be also following other safety norms, like it should have 3-point contact with the surfaces. These ladders are also used for material movement or tools and tackles movements. So these are also used for building construction and used for above floor stories as well. The other category of equipments and vehicles analyzed here include trailer trucks, dumpster vehicles, and these all are using IS Indian Standard Code guidelines, that is 7293, that was developed in 1974. It suggests that there should be at least a clearance of 0.6 meter between the trucks and the superstructure of the shovel or excavator or any other object that is being very nearby to the trailer or the oil tanker vehicle in this case. Here we have shown the other examples of the site equipments that will be discussed and will be following this same guideline. So here the lack of guideline for individual equipment is observed, and here we can also identify that there was no any particular regulation floated or generated or drafted by OSHA. So we have used the Indian Standard Code. Here we have shown the clearance zone by showing red clearance blocks that are created around the trailer vehicles, tank vehicles, and it is already seen that this is at least at a distance of 0.6 meter. As discussed in the previous slide, these are the construction equipment that will be following the same IS code guideline of having a clearance of 0.6 meter or 1 foot 11 inches 9 by 19 by 32 fractions. So this will be a generalized guideline, as an specific or a individual guideline for the equipment is not available. So we have modeled following the IS code guideline. Here we can see the families of concrete pump truck, then concrete pump, then dump truck, and the dozer family is observed in this. Here we can see the clearance distance is kept as 0.6 meter, and it is denoted by the clearance blocks in the red. Here we have shown the top view or the plan view and the ISO view for the better understanding. In this part of the data analysis, here we are discussing the concrete pump truck, that is the boom placer truck, or generally known as the boom placer. Here we have shown the safety guideline is not currently available with the OSHA's guideline. So the guide has suggested these norms and we have been modeling with the help of these norms. So the minimum setup with the help of the safe distance from power lines is at least 20 feet away, and barricading and other means should be provided near the hopper by area. So we have kept a clearance of 29 feet, which is almost greater than the equipment length, and we have kept barricading near the hopper area. Here we have shown in the plan view and the ISO view. The red colored ring shows the clearance for the equipment. For the excavator, here we have been following the Indian Standard Code guideline, that is 729 through 1974. Here it suggests that the voltage in the power line and the minimum clearance distance should be as given in the table. For 11 kilowatt and below, it should be 1.4 meter. So here we have shown the separate distinct cases of the excavator clearance distance based on the power line voltage. Here we can see the 5 different cases, and it is represented by the increase in the clearance distance as with the increase in the voltage of the clearance line. The red colored ring shows the clearance distance from the equipment with respect to the power line, that is surrounding the equipment if there is any. Here, the hoist family has been discussed. The hoist is generally used for transferring materials at upper stories of the building, and the personal hoist is used for the man movement to the upper stories from the lower parts of the building. Here, there is an absence of guideline observed from the OSHA. So here, the guide of this study has suggested using this guideline based on his experience and the nearby OSHA guidelines that has been studied. So within 6 feet of any hoistway, there should be an clearance available from the interior side, while for the exterior side, there should be a clearance of at least 10 feet from the exterior perimeter of the building. So based on this guideline, for both the types of the hoist, material as well as personal, this kind of safety ring and blocks are modeled. So here these are parametric. If we want to change the distances, we can just enter the parameters and can change the 6 feet or 10 feet criteria as per the requirement of the site and the safety personnel present on the site. In this part of the data analysis section, we will be going through certain crane equipment family. So these are the crane equipment family that will be discussed. Crawler crane, crane that works for all terrain, luffer crane or the tower crane. And this is the modeling process flowchart for developing the safety clearance around the crane families. So first of all, we have to load the equipment in the brevet. Then based on the reference planes, using the base arm length as a parameter, we have to draw another reference plane starting from the base arm length at a distance and have to give that distance as a parameter of clearance zone. Then in another Revit file, we have to create the same reference planes and have to make an extrusion object by having a shape of ring, and then we have to import this ring extrusion into the parent file that has the site equipment vehicle family, and then we have to link both the files and lock it. Now with the help of this clearance zone parameter, we can increase or decrease the clearance zones based on the safety guidelines provided by OSHA or the respective guideline for the family that is in place. First construction equipment that is modeled for the safety aspect is the cranes, that is specifically the luffer crane. Here we can see the guideline of OSHA 3433 that is followed, and the safety parameters of work zone and the barricades are shown here. Here the guideline states that 10 feet away must be the minimum barricade distance, so it is addressed in the model as well. An additional fall zone protection has been also modeled. So this fall zone protection covers the area that is under the lifting zone or that has any weight or any object that is being lifted and has a chances of falling from height or falling on an subject, or it has the chances of hitting or striking by an object or human or any other part of the site that is being constructed. The Laffer crane model family is created in such a manner that when we change the vertical angle of the arm, the total operating radius also decreases or increases depending upon the angle. Here we can see at 0 degree the maximum radius is observed and at 90 degree the minimum radius is observed. Similarly, the radius is linked with the work zone that is shown in the gray color band and it also changes accordingly. One of the other parameters that has been modeled is the safe distance or the clearance from the power lines. So here we can found the trend that as the voltage of the power line increases, the clearance distance also increases. For 50 volt or below, the 10 feet distance is observed, which increases up to 45 feet for the voltage up to 750 to 1000 level of voltage in the power lines. So this work zone radius is also dynamically modeled to change with respect to the voltage in the power lines. Similar to the modeling of the equipment family of the Laffer crane, the crawler crane family has also been developed. Here with the angle of change in the degree, here with the angle of change in the boom angle, we can find out that the angle of verticality will change and this will also increase or decrease the clearance zone around the crawler crane equipment. As observed in the Laffer crane, the voltage of the power line decides the clearance distance for the crane equipment. The same rule applies for the crawler crane as well. As the voltage increases, the clearance distance also increases. The same has been represented with several instances of voltages and the clearance distances. This is specially modeled for the crawler crane as well. This distance is a parametric distance and can be assigned for different power lines by just a click of a mouse, and you can always set based on the site requirements. Since it is a parametric family, you can always try to address the safety standards and play within the range of the clearance areas. The next model site object for the safety perspective is the safety net. These nets are always found out to be effective in terms of fall protection where there are open edges or there is an opening that is uncovered and there are high chances of falling of debris and construction, other wastage materials or other raw materials on workers, and there are also chances of hitting by. So these safety nets are modeled such that they have been following the guideline of OSHA subparty, and the guideline suggests that there should be not exceed the mesh size by 6 inches by 6 inches. So 36 square inch square should be the area between the opening of mesh. So this mesh has been designed in such a manner that the basic and the minimum 6 inch by 6 inch requirement is always satisfied, while you can also change the operational angle when this mesh is attached to a surface edge. So in case if you want to just incline or decline with the surface of wall, you can always change in the operational angle. The length and width of the safety net are parametric and customizable, so you can increase or decrease the length of the width depending upon the construction site equipment. The safety net follows the guideline of minimum 8 feet projection from the edge of the work where it is happening, and this safety net is always modeled that you can always increase from 8 inch to 13 inch or let's say 25 inch. It depends on the site condition, and the net has the provision for increasing or decreasing the length and width. The next object pertaining to construction site safety that has been modeled is the fire extinguisher. This follows the subpart F for fire protection and prevention of the OSHA part 1926. The important guidelines are that no area should exceed 3000 square feet without the protection of fire extinguishers. The distance should not exceed greater than 100 feet and there should be fire extinguisher on each floor. To mitigate this guidelines, we have modeled in protection area ring that has a diameter of 100 feet. So when you place the excavator model family in a pilot project or a 3D project, you can observe the distance between the two extinguishers and you can figure out if the distance is more than 100 feet or less than 100 feet. This helps in better modeling and visualization and also helps for placing the fire extinguishers. Overall, we can briefly say these are the benefits of the Revit parametric families. It provides design accuracies and has dependable design building components of barriers and other safety critical parts. The early safety issues can be detected and various design possibilities can be made with the help of these parametric families. Standardization has been a key point that has been kind of achieved with the help of these parametric families, because you can always circulate these parameters within your building model and your organization to avoid irregularities by individual modular loaded families. This can be a standard common point of reference, while optimized documentation can be carried out with the help of these families. We can always extract information like numbers, measurement, and instances of the objects that are placed in the Revit. Output can be already generated based on the equipment that you have loaded in the model, and optimized output document can be prepared of the families that are in the model. Now moving to the 4D visualization part. This involves incorporating the schedule or the time dimension to the 3D model. The inputs required for the developing a 4D visualization or the 4D animation are Revit 3D model, construction schedule, and the Synchro 4D Pro helps to develop this visualization in terms of the appearance and the other properties that we will be discussing in the later part. The process for developing this visualization is, first we have to modify the pilot project that we have received based on the outputs that we require. We have to set certain views and have to create certain worksets that we will be discussing in the next part. The integration of then this BIM model of Revit and the Synchro 4D Pro software is to be done, and 4D animation and other settings are to be enhanced and customized in the Synchro software for generating this 4D animation. Now, there are several benefits of integrating this 3D model with the time schedule and developing 4D visualization. Now, talking with specific contexts of Revit parametric families, they promote accurate design, early detection of issues, coordination is improved, and visual representation of the complete process of the construction has been also able to help in terms of the construction safety aspects. The 4D visualization part is now explained in terms of the Revit model modifications that we have to do. Here the pilot project brief is given. It is a mixed use project. It has 3 floors in each tower. So there are 2 towers A and B. In between there is a lobby area and each tower is of 11-story high. So the pile foundation is the type of structure system that is supporting the pilot project of 11 stories high. So here we have taken this Revit model for developing the 4D visualization and to test our Revit family of equipments and other objects that we have created to check how these safety centric parametric families are helpful for enhancing visualization in terms of construction safety domain. Now, as I spoke earlier, one of the modification in the Revit model is to develop certain work sets in which we can work with collaboration and without interfering or disturbing other work sharing partners that are working on this Revit model. Here, there are work sets developed for safety equipments in terms of superstructure, substructure, and the landscape. For this substructure OSHA workset, here we have placed the equipment families that will be used in the substructure part. On the next, we'll explain several other worksets and their respective families. Here, if we have the active workset of substructure, the other families or the loaded families in this workset are only active for this worksets, and whenever we try to export this workset, only this equipment, let's say in case dozers, dump truck and excavator will be only exported while the others won't be because these are not actively present in the OSHA substructure workset. Similarly, the other worksets including OSHA superstructure workset and the landscape workset are shown here, in which we can see both the different worksets have their own different equipments like dump trucks and dozers for the landscape workset that are included in the road works, while structural workset has the concrete elements and equipment, that is the concrete truck and pump, while here we can see the superstructure workset also has the fire extinguisher that are placed once the superstructure work of that particular floor has been already completed. Here we can see the red zones showing the clearance areas, and there are red rings and red safety clearance blocks that are visible in the superstructure workset. These are clearance blocks that are parametric and have been modeled in such a manner that we can increase or decrease based on the project requirement, but it should always adhere to the OSHA safety standards that it has been particularly modeled for. Here, the steps for linking the Revit model in Synchro 4D Pro is given. First, we need to then apply the appearance profile to the 3D objects that are loaded in the Synchro, and these appearance profiles have different types of simulation, and growth simulations are also part of the appearance profile. Here we can decide based on the color or based on the type of simulation from top to bottom, left to right or up to down, how the appearance profile for that 3D object will be developed. Then next is to develop the 3D paths in the Synchro 4D Pro. Now the 3D paths are the resource having particular movement of that equipment, and for a particular task that resource will be assigned to a particular 3D path that will be moving for the certain task that it is assigned to. Now the third step is for developing an animation video from the Synchro profile. This is combining all the appearance profile and the 3D path. So if an example, an excavator is assigned a task of foundation work and that to excavation, the appearance profile will be in the direction of the foundation work, and it will go from the excavation pit till the end of the excavation, and there will be a 3D path assigned from the start of the excavation to the end of the excavation pit, and this whole will be followed by the equipment of the excavator and can be easily viewed from the animation video that is developed from the 4D Synchro Pro output. The previous steps of linking the Revit model 3D object with the Synchro Pro files are explained here with the help of snapshots from the Synchro 4D Pro software. So first, on the right hand side we can see the appearance profile we can set. So here we have, let's say, custom profiles made for excavation for concrete work, and we can set the appearance with the help of the original color or the other colors if you want to show. The growth simulation can be also assigned. The next step is to assign that resource a particular 3D path, and here we have shown a list of 3D paths. The 3D paths are shown in the figure with the help of red lines, and there are arrows pointing the direction of the movement of the resource. On the last screenshot we can see the animation video settings, wherein you can adjust based on the requirement of the output. You can always adjust the resolution, content, soundtrack if you want to add for better aesthetic and pleasing understanding and visualization output, while you can always add text frames, let's say sample project 1 or the importance of the several other notes that if you want in the animated output, you can always add it in the text frames. So this will be then a step by which the animation video output from Synchro 4D can be exported. Now we will see certain snapshots of the Synchro 4D visualization. This will be a certain project stage where the Synchro 4D output video has been paused and taken a screenshot. The Synchro 4D Pro visualization has not been added in terms of a video output in this presentation due to the heavy file size and a restriction from the guide to add the video. We have added several screenshots that will represent the whole video at different stages of the key phase of the project. The pilot project Synchro 4D video can be seen at the start of the construction phase in this screenshot. Here we can see the excavation work has been started and the dozer equipment are here doing the temporary road works, which is highlighted in the red part, and there are certain other building surroundings which we can observe in this model that are loaded, while the next one will be at the different phase, but this is captured at the construction start phase for the understanding of the project site location and how the other facilities nearby the site are. In this screenshot of the video output of the 4D Synchro Pro animation, we can see the pilot project is at the structural work start phase. On the right hand side, we can see the green patch that shows the starting of the foundation of and the grade slab has been started. Here we can see two tower cranes have been established. The red colored zones around the tower crane shows the visibility of the clearance zones, and these are with respect to the power lines they have been facing at the current site location. Here we can see the piles have been erected and the columns for the ground floor have been casted. The next will be at the different stage of the project and we'll see in the further slide. During the end of the structural work, when the complete RCC and the concreting work has been completed, the pilot project Synchro in the 4D video output looks something like this. The screenshot helps us to see that the facade works for the tower B have been now started, and this shows there are crawler cranes with the safety zones being modeled, being started the work. Their work in progress is at the current roof stage for the tower A. The tower cranes have been also observed that are crossing paths with the electric lines in the bottom of the image. So for careful operations, this kind of safety zones being modeled are always helpful for identification of such clashes between the electrical lines, and we will see this in a comparative manner for the next slide. Here we can see one of the screenshot has been captured at the end of the facade work phase. So tower A facade work is the last activity going on, and here we can see the other tower cranes have been demolished or have been dismantled, to be correct, while the crawler crane working with this facade has been still employed. Here we can see the other landscape and hardscape work will now begin because the ground has been cleared and the other vegetation have been removed, and this is a make ready condition for the other works to begin. From this particular angle of the screenshot that has been taken, here we can see the hardscape and landscape work phase has been started for this project, and nearby the tower B area, the landscape and the hardscape work has been in progress and have been completed up to a bit, while near the tower A area there has been movement of dump trucks and dozers, which means it is still in the starting phase and the progress has yet to be come. While nearby tower B area we can see the dozer is present, so this shows the road works is in the finishing stage and will be completed, and the hardscape and landscape final images will be shown in the next slides. Here we can see the final image at the construction end phase with all the hardscape and landscape work done. All the towers with the facade works and the concreting and complete structural work has been completed. Here we can see how the complete project looks at the end with the help of the synchro output. Here we can observe in the earlier manner that what will be the final output, what will be the time duration of construction, and how there will be a better possible manner to construct the building with the help of the safety parametric families that we have loaded can be observed with the help of such outputs which are developed by both the professional capabilities of the softwares of BIM and Synchro 4D Pro. Here we have given comparison between two models with same project, one with Revit parametric families for the safety in the construction field. Here we can see two images showing different tower cranes, one with safety clearance added as per the guidelines and the discussion we have been doing for the safety objects around the construction equipment, while other is without the safety clearance. Here in the images we can see red circles that denotes the power lines that are crossing the project and they are lying in the operational radius of these cranes. These are the four kind of major highlights which helps us to understand the importance of this safety clearance that is developed and in a parametric manner. So accidental touch or interface or any clashes can be reserved and stopped before the crane operations begin by the help of this modeling, and this can also significantly improve the construction safety because this clearance stops accidents, in turn helps to reduce the kind of rework or the project delay time, because if there is accident or any lapses there will be lot of uh, injury, or let's say construction will be halted for some time and that will always cost in some money. The Revit family of the safety net here in one of the towers of the building has been shown, while the other location with the same project has been found without the safety net. The provision of such safety net in the 4D model or the 3D BIM model can help to visualize the project professionals before construction how the safety net will assemble at the place and how it will protect the workers from the falls. This can reduce the likelihood of accidents and injuries on the job site. Here, as discussed about the fire extinguisher family that we have developed, the model has fire extinguisher placed at all stories, while the other model with the same project and same location does not have fire extinguisher placed. So this shows how there are higher chances of accidents and incidents that can lead to the medical expenditure, and compensation can be of high in volume, while whenever there is a provision of fire extinguisher we can always find out the protected area and try to restrict the fire within the nearby zones of its source, and where we can also identify potential hazards, and to prevent them we can enforce the measures from the very beginning because of the early safety issue detection that we can be able to do with the help of this Revit parametric families. We will be now moving on to the summary and the conclusion part of this research study. For the concluding remarks, I would start with BIM offers a visual representation of site and workplace, increasing awareness for hazard detection before execution, while the research studies here focus to develop parametric Revit families for the models in construction, and there were several equipment that have been identified and modeled with an aspect of safety in terms of clearance and other guardrails or fences that have been modeled around the equipment, while safety parameters help to focus with the standard clearance zones, and fall protection can be improved with the help of such parametric families. While the primary survey or the preliminary awareness survey in the study helped to identify that the contractors and the PM consultants have a growing awareness and adaptation for the BIM technology in the industry. These safety parametric families in planning phase, if employed and incorporated correctly and in a correct manner, can help to ensure safe and efficient construction process. The chances of accidents or hazardous safe or unsafe practices can be reduced to a certain amount, which is very much helpful for the progress of this construction industry because it lowers the chances of construction accident on the project, which in turn helps to reduce the number of delays the construction project has been facing. The study limitations that can be incorporated for the next studies of this nature or to be avoided for such studies are listed here. The study limitations include absence of HSC professionals in the survey respondents. While there were a preliminary structured physical semi-structured interviews, but the respondents were not being captured from HSC professionals for the survey. The guidelines equipment were limited as we spoke about. There were not all equipment having OSHA guideline or any other international or national guideline was available. The market validation is must for the next studies which can help to improve the reliability. Revit software has interoperability issues. While working with a higher version of the software, you can't open the files in the lower version. That is one of the interoperability issues. Time consuming export of animation videos for the Synchro 4D Pro. This results in software clashing and sometimes taking more time than expected. While performance issues occur for the Revit software when there are multiple families that are loaded in this software, and this might take some time to resume back its normal operation. The focus here is mostly on the construction equipment part in this study, and there are certain objects, but there should be a focus on overall construction safety in terms of occupational hazards and all the fatal four kind of hazards that OSHA has suggested. So this is one of the limitations of the studies as well. Now, some of the key points that can help to identify how the studies can be enhanced in a better way in the future are highlighted in this section. The inclusion of HSC professionals' perspective should be taken care while these studies are carried out in the future. Validation of Revit families and Synchro 4D simulations should be done with the help of actual projects and comparing with the construction stakeholders on site. This kind of projects or simulations can be always enhanced with the help of latest technology of virtual reality. This can help to generate better training modules for site professionals and workers. The scope for Revit families with the help of safety aspects can be further more widened in terms of protection of personal body based injuries while modeling PPEs. Temporary barriers or fences can be more detailed about, while integration of Synchro 4D Pro and Unreal Engine can be also in further scope, which helps to visualize and effectively understand the output, which because of its high quality renders and visualization that are developed from Unreal Engine. This has a more realistic and aesthetically appealing output generated from the Unreal Engine, while enhancing the construction site safety with machine learning based analysis can be also help to develop proactive measures to prevent accidents and injuries on the construction site. Here we have shown the list of the references of the articles and the sources from where these articles have been referred. This is the secondary references that we have been presented here. Finally, I would appreciate and thank you for taking out time from your schedule to go through this presentation. I would like to thank SEPT University for providing me this opportunity to conduct the directed research project at SEPT University, and thank you again for taking a time for this presentation. If you have any feedbacks or comments, please contact us through the details in the presentations given. Thank you very much.